Hi everyone, today we're going to go over section 1.7 with modeling equations. So we're going to be going over some problems about interest, area or length, about mixtures, and about the time you need to do a job, about distance, rate, and time. So to begin, a mathematical model is an equation that describes a real-world object or process. So we're going to be using mathematical formulas and equations to apply the math that we've learned so far. So some guidelines in setting up a mathematical model. Our first is to identify the variable. So the variable that we are trying to solve for. And then we also introduce notation. So is the variable that we're trying to solve for a length? Is it in feet? Is it gallons? Is it a measure? What is it? And then we're going to translate from the word problem to algebra. So we're going to express quantities in terms of the variable from 1. Now I know that's easier said than done, but we're going to go ahead and go through this and go through examples and try to practice it. And then we set up the model. So we set up the relationship between expressions in 2. Then we solve the equation and make sure our answer is logical. For example, a negative length is not a logical answer to get at the end of solving a model. So in order to get us set up for this next problem, we're going to learn about interest. So the simple interest formula is I equals PRT, where I is the total interest fee, P is the principal P, which means the loan or the deposit amount that's they're collecting interest. The interest rate is R, and then remember to convert our R from a percent to a decimal, and then time is in years for T. So our example is Mary inherits $100,000 and invests it in 2 certificates of deposit. One certificate pays 6% and the other pays 4.5% simple interest annually. If Mary's total interest is $5,025 per year, how much money is invested at each rate? Okay, so we're going to look for what are we trying to solve. So we're trying to solve the amount of money invested at each rate. So I'm going to let X equal the amount of money invested in the 6% rate. So she inherited $100,000. So we're going to do the amount invested at 4.5% is going to end up being 100,000 minus X, because we're splitting it into 2. So she has the 100,000 and she's splitting it into 2 parts. So we already took out X, which is the amount that she invested in 6, and what we're left with is what she invested in the 4.5. So our interest that we accumulate with the 6% interest rate, we're letting that equal to 0.06x because we changed the 6% to a decimal. The interest earned at 4.5%, we're going to take 0.045, and the amount that we invested in the 4.5, which we know from above was 100,000 minus X. And we know our total interest was 5,025. So our interest at 6% plus our interest at 4.5% is equal to our total interest. So we're going to go ahead and take the values from the table and plug them in. So we're adding the 2 and then setting it equal to the total interest. So here we just distribute our 0.045 to both, and then we're going to solve for X. So we get 0.015x equals 525. So our X is 525 over 0.015, which ends up being 35,000. So she invested $35,000 in the amount of the 6% certificate, and then we subtract $100,000 minus $35,000 because of this here. So she invested $65,000 in the 4.5% certificate. So those are the amount of money that is invested in each rate. And do take some time after these word problems to just pause the video and reflect on them on your own. It is a lot to think about, so it's good to just pause them as we go through and make sure you check for understanding. So area or length. A rectangular building lot is 8 feet longer than it is wide and it has an area of 2,900 feet squared. We want to find the dimensions of the lot, where W equals the width of the lot. So as the length is 8 feet longer than it is wide, we know L equals W plus 8 because it's 8 feet longer than the width. So we know area of a rectangle is length times width. So we're going to go ahead and plug in those dimensions. So we're going to distribute the W. We get W squared plus 8W equals 2,900. We're going to set up our quadratic equation. So we have W squared plus 8W minus 2,900 equals 0. We'll factor, and this is kind of a difficult one to factor, so I just have it W minus 50, W plus 58 equals 0. Therefore, W equals 50 or W equals negative 58. As width or like measurements have to be positive, so we could neglect the W equals negative 58 because that's not a logical answer. So our width is 50 feet, and then we want the dimensions, so we also have to find the length. So we know length was the width plus 8, so our length is 58 feet. Alright, so here we're going to determine the height of a building using similar triangles. So a man who is 6 feet tall wants to find the height of a 4-story building. So the building's shadow, it's one building. The building's shadow is 28 feet long, and his shadow is 3.5 feet long. So how tall is the building? So I just drew a picture here. It's really helpful to draw pictures or tables in modeling. So this guy, he measured the shadow of the building, and that was 28 feet. And then we have the height on the other side. And then he knows that his height is 6 feet, and then his shadow is 3.5 feet. So here we see that because there's a right angle between them, and the angles are the same, that these are similar triangles. So we're going to go ahead and use similar triangles as a ratio of corresponding sides are equal in order to find the height. So our ratios are going to be height to base. So for the large triangle, the height to base ratio is h over 28. And then the height to base ratio of the small triangle is 6 over 3.5. We're going to go ahead and set those proportions or ratios equal to each other. And then when you do those, you're going to do height times 3.5. So 3.5h, and then 6 times 28. So we have height equals 6 times 28 over 3.5, which is 48. So we know the building is 48 feet tall. Okay, here's an example of a mixture problem. So if X amount of a substance is dissolved in a solution with the volume V, then the concentration C of the substance is given by C equals X over V. And this you can find in your book. So an example of this. So a soft drink company makes orange soda, and they claim that it's naturally flavored with 5% orange juice. But then there's a new law that's released that say in order to be natural orange juice, you have to have 10% fruit juice. So we need to figure out how much orange juice the company has to add to a 900 gallon of orange soda to conform to these new regulations. So let's set X equal to the amount in gallons of pure orange juice that needs to be added to the already made 900 gallons of orange soda. Okay, so we're setting the amount of orange juice to be added is X. So the amount of mixture that we're going to have is going to be that, let me put gallons here so it's a little bit easier. Okay, so the amount of our total mixture in the end is going to be that 900 gallons we already have made, plus however many gallons of fruit juice we're going to need to add to it to get it up to code. So our amount of orange juice in our first mix is going to be that 900 gallons times 0.05. So that's how much orange juice is in there. So we know there's 45 gallons of orange juice in the first mixture. And then the amount of orange juice in the second mixture, that's just going to be 100% because we're just pouring in orange juice in order to get it up to code. So the amount of orange juice in the total in that mix, it is going to be 10% of 900 plus X. That's what we want it to be in the final mixture. So the 900 plus X is the gallons, and then the 10% is the amount of orange juice that we want in there. So here's a picture depicting what was in the table. It helps to draw out pictures. So this is the first mixture. So we have 900 gallons here, and then we have 5% orange juice. So that's 45. Our second mixture is the X gallons, and it's 100% of orange juice. So we have X. So our last mixture, when we combine those, it's going to be 900 plus X gallons. And we want 10% of orange juice. So we're going to take 0.1 times 900 plus X. So let's go ahead and write that in an equation. So we have 45 plus X equals 90 plus 0.1x when we distribute the 0.1. And then we get 0.9x equals 45. So our x equals 45 over 0.9, which is 50 gallons. So we need to add, so the original question was, how much orange juice must we add? So we must add 50 gallons in order to get it up to code of 10% orange juice. Okay, now we're going to do the amount of time to do a job. So the water level of some place has to be lowered by a foot. So opening spillway A lowers the level by this amount in 4 hours. Spillway B does this in 6 hours. So spillway B is slower than spillway A. How long will it take to lower the water level by 1 foot if both spillways are open? So let X equals the time in hours to lower water levels by 1 foot if both spillways are open, because that's what we want to solve for. So we want to look at a fraction or a portion of the job that can be done in an hour by each spillway. So we want to analyze that and then look at what portions together can complete the job. So something to not do is we don't want to just add 4 plus 6 and say that if both spillways are open, it'll take 10 hours to lower it by a foot. This doesn't make sense because if spillway A can do it in 4 hours, that means that it would be slower by adding someone else to help them, which does not make sense here. So we'll go ahead and proceed. So the time to lower 1 foot with A and B, we're saying is X. So the distance A spillway A lowers the level in an hour is 1/4 of a foot, because it's able, basically in 1 hour, we're going to get 1/4 of what we could do in 4 hours. And then distance B lowers this level in an hour by 1/6 feet, because we're going to be able to lower, in an hour, we're only going to be able to do 1/6 of what we would be able to do in 6 hours. So the distance A and B together lower the levels in 1 hour is 1/x. So the A and B lowering the level in an hour with the fractions, that's like the portion that it could do in an hour. Okay, so we're going to do the fraction done by A plus the fraction done by B equals the fraction done by both. So we have 1/4 plus 1/6 equals 1x. So we're going to multiply by the least common denominator, 12x. And then we're able to cancel out common factors to get 3x plus 2x equals 12. So our 5x equals 12 and x equals 12/5. Just a comment that I want to make again about the fractions. So 4 is because it's 4 hours, and then the 1/6 is because it takes it 6 hours to lower it 1 foot. So overall, it will take 2 2/5 hours to lower water level by 1 foot if both spillways are open. So take a look at this. Really make sure you understand the fractions and the portions involving A and B. Okay, here's a distance equals rate times time. Rate is also known as speed. So a jet from New York to LA travels a distance. I forgot to add travels. A distance of 4,200 kilometers. The speed of the return trip was 100 kilometers an hour faster than the outbound speed. So the total trip was 13 hours. So we want to find what was the speed from New York to LA. So let S equals the speed from New York to LA. And our S plus 100 is the speed from LA to New York, because it traveled 100 kilometers faster than the outbound speed. So here's our little chart. We have New York to LA and LA to New York. So the distance we know for both of those is 4,200, because that's given. Our speed, we define New York to LA as S, and LA to New York is S plus 100. And that the time is going to be our distance equals speed times time formula. And then when you get time by itself, that's d/s. So we're just going to take our previous columns and use those. So we have New York to LA, time is 4,200 over S. And LA to New York is 4,200 over S plus 100. So we see that the time for New York to LA plus the time for LA to New York is our total time. So we're going to go ahead and use our table to plug in for the values. So we have 4,200 over S plus 4,200 over S plus 100. And we know the total trip was 13 hours. So go ahead and multiply by the least common denominator, which is S times S plus 100. In order to get rid of the denominator in the fractions. So we have 4,200 S times S plus 100 plus 4,200 S equals 13S times S plus 100. So basically we're going to simplify, and then we get our quadratic equation. Now, these numbers are really, really big. So our x factoring would be pretty difficult in this equation. So instead, we're going to just go ahead and proceed with the quadratic formula. So we'll plug in our values for a, b, and c, simplify, and then we get 7,100 plus or minus 8,500 over 26. So our s is going to be 600, or s equals negative 53.8. So we can reject the negative 53.8 because what are we trying to solve for? The speed. So we don't really have a negative speed unless we're talking about velocity. But here we're talking about speed. So we're going to say our s is equal to 600 kilometers an hour. Okay, that's it for this lesson, and that's it for the lessons this week. I'm going to go ahead and post the updated syllabus, hopefully by Friday, and that will have the readings for next week and just how we're going to proceed through the course. I'll also be posting that practice quiz on Friday. I'll let you guys know when it's up. I'll send you an email. I'm going to go ahead and keep it open all day on Friday. But just know that for the actual quiz, there's going to be a time limit and the quiz will close. But I just want you guys to know where to find the quiz and then also how to upload things. So you guys can go ahead and practice that. There won't be anything actually on the practice quiz on Friday. So it's just going to be fake things on there. So you don't really need to do anything. I'm just asking you to practice. You don't need to solve any problems or anything. But we'll go ahead and do that. I also posted the homework up for this week, so go ahead and check that out, and that'll be due Monday. If you guys have any questions, I'll see you in office hours. Thanks.